Alright, this is the last problem of section 11.3, the derivative as a rate of change. Problem number 42. Revenue. For a certain manufacturer, the revenue obtained from the sale of Q units of a product is given by R equals 10Q minus 0.2 Q squared A. How fast does R change with respect to Q? And then we're supposed to evaluate it at Q equals 25. So how fast does revenue change with respect to quantity? That's the derivative of revenue with respect to quantity, or also known as marginal revenue. So the derivative of 10Q is 10. The derivative of 0.02 Q squared is 0.4 Q. And now we want to evaluate this at the quantity level of 25. So 10 minus 0.4 times 25, which equals 10 minus 0.4 times 25. 0.4 times 25. It's 0. So the derivative, so the marginal revenue for producing one more unit of output at the output level of 25 units is going to be 0. So there's no revenue to be gained by producing more that by producing that 26th unit. Alright, B. Find the relative rate of change of R. So the relative rate of change of R is the derivative divided by the original function. So dr dq divided by r, so that's going to equal 10 minus 0.4q over 10q minus 0.2q squared. That's the relative rate of change. And now we want to evaluate the relative rate of change. Actually, we're not being asked to evaluate it, so forget that part. C, to the nearest percent, find the percent rate of change of R. So the percent rate of change of R is going to be the relative rate of change times 100. It doesn't ask us to evaluate it, so but for the sake of just being able to do something on this problem, let's evaluate it, the relative rate of change at an output level of 25, and then we'll get the percent rate of change. So 10 minus, so actually we figured out that 10 minus 0.4, we figured out the numerator is going to be 0. So thus the relative rate of change is 0, and the percent rate of change is 0 as well. So those are our answers. And that's it. We're done with the problem. And we're done with the section. Congrats.